close to the Women Who Build Summit. And with me today is Kayleigh. She is going to be speaking on the 27th, right? Mm-hmm. On a panel called Robots, AI, and Blockchain. Where is technology taking us? So, Kayleigh, give us a brief introduction about yourself, how you got here today.
Sure. So I am an associate principal and the computational projects lead for Buro Happold Engineering, which is a global engineering firm, about 2,500 people with 23 offices globally. My introduction to technology actually started back in 2009. I joined a firm called Kling Stubbins in Philadelphia, and on my first day, they're giving Revit training. And I thought, this is so much more exciting than the actual engineering that I want to be doing for the buildings and the built environment. So I actually latched on to, I guess, the BIM kind of train very early on in its introduction to the industry. And that's kind of snowballed from there. So I learned visual programming. I became a part of the computational department at Buro Happold about 6 years ago now. And now I am part of co-leading an open source platform called BHoM. So really just democratizing the ability to have interoperability between different software platforms and being able to code together with computer scientists and engineers, and really kind of getting the best of the domain expertise that everyone has in the AEC industry and encoding that. And just being able to do so much more than we thought possible, so much more than just producing drawings and designs, and really kind of optimizing when possible. So it's a really exciting time to be a part of engineering, and especially kind of blending that in with computer science. So
that is really exciting. And it's nice to see your passion on this topic, like kind of being the glue that binds a lot of these approaches that are going on right now. I am very curious because I have not heard this term before, and maybe I'm out of it now, but please explain for me and anyone else watching, what the heck is computational design?
It's a good question. So I think people call it digital design, computational design. At Buro Happold, we call it computational engineering. It really is just taking the approach of a computational mindset and applying that to your domain expertise, whether you're an architect or in construction management or in engineering, kind of thinking like a computer, if that makes sense, and applying that logic to the workflows that you do to be able to do more of what you actually enjoy rather than the kind of monotonous tasks. We're actually using computation for more innovative solutions to problems like environmental issues or social issues or health issues, and being able to meld that in with your design.
There have been conversations about how, while we may have been, we transformed from the analog world to the digital world, we still think in analog, even if our records are digital. Can you explain a little bit of the difference between analog thinking versus actually changing our mindsets and thinking more like a computer, more digital? Like, make that real for people who are not in your space.
Sure. I think a really good way of thinking about this is when you're working in a BIM model, you have objects inside of that model, whether it's a duct or a wall or a column. Those objects that you're drawing, you think you're drawing lines on paper, right, for documentation. At the end of the day, you probably deliver a 2D deliverable. I think that's changing a little bit, but that's what it is. However, you can actually use that object, all the properties inside of it, to be able to kind of parametrically control it if you want to. So if there are rules around something, let's say maybe the bay sizing that you might do for structural engineering or duct sizing you might do for mechanical engineering, you can set up rules in something like a visual programming script or code. You can encode your domain expertise to be able to do some of those processes for you because of the attributes that live on the object. So the open source platform that Buro Happold open sourced in 2018 is called the Buildings and Habitats Object Model, because really it's about the domain experts. So architects should define walls. The structural engineers should define what a column's properties are. Mechanical engineers should design what a duct's properties are. So really kind of giving that back to the experts so that they can define it and then define what you do with it, what the engine methods are that sit around it. So hopefully that helps kind of in defining how you can take something that feels like a 2D deliverable and really using it in the smartest way possible.
So what's new and different about where we are now versus where we were? So in the early 2000s was the first time that I was working in CAD with objects, blocks, with properties, being able to export, list data sets based on how well you used those features, like the object properties and things like that, so that you could then leverage them to the next step. That's been around for a really long time. But you said something that sounds different now than was then, was like how you choose to use that information. So it's more than just creating like a database and collecting data inside of a 2D or a 3D model. There's another step there that we're going to with the technology, right? So can you kind of peel that a little bit more for me? Because we do so much that we've had so much for a long time, and deployment throughout the width and depth of the AEC industry has always been a challenge. But now we're even moving ahead further and faster. So there's a lot of catch up, I think, for many organizations to do. And so I think with your expertise and this conversation, we might be able to show how it's really it's that, and it's not like there's no yet like but statement here. There's yes and going on. So it's the and part. So people may have been exposed to some of the earlier pieces, and yes, we have objects and properties and all that other stuff in our deal, and we can pull out the data and it really streamlines things, but that doesn't cover the now and tomorrow. Did I frame that in a way that makes any sense?
You did. And I think the best kind of embodiment of that and statement is the ability to tack on a property like the embodied carbon of an object. Let's say that a column is a certain size, it's a certain volume, it has a certain mass associated with these kind of functional units. In addition to something like if it's made out of concrete, you'd have a water to cement ratio, right? So the properties that are defined can also now help to tap into something like the embodied carbon attributes. So if you attach an environmental product declaration, kind of is the embodiment of that data for the embodied carbon. If you attach that to your column now, and let's say that it's a volume-based EPD, you can now measure your embodied carbon as your design is kind of forming and flexing, or you add more columns, or you change out the material. You're able to attach these additional attributes to just make your design smarter, better for the environment. I think we're now just at that edge of starting to add on those environmental attributes kind of en masse. You want to be smart about that, obviously. And I think also there's an aspect there where you're democratizing sustainability expertise, because traditionally that's something that sits with a very small group. Maybe they're inside of your company, maybe you hire them as an outside consultant, but you don't want that to be something that happens when your design's already done, you've gone out for construction documents, you're thinking about the embodied carbon, then no, you need to think about it very early in the design. So I think trying to attach that expertise as early as you possibly can, use it in the smartest way you can to really think about that additional attribute when you're saying, do I want a mass timber building or do I want, steel or concrete? Thinking about those with that additional facet, thinking about the healthiness of your materials. You don't want the occupants of your building to get cancer one day because of your poor material choice, because we're asked to think about so many other things at this point outside of our own kind of structural engineering expertise, for example, that you can't do that without the help of a computer. Like it would not be possible to be able to do all those iterations of different designs and using generative design in addition to thinking about all these other facets that are really important for the planet.
So this is incredibly interesting. What are the data sources for that information? Is this something that each engineering firm codes in themselves? Is it something that material suppliers are providing? Is there a Library of Congress similar thing where all this data is sitting in for each of the materials? So the technology is allowing you to be able to enter in this information and then leverage it. But then my very next question is, what is the reliable data source to actually plug in that information so that you can use it with confidence the next step down?
So that's a really great question, and it's very complicated as an answer. So in addition to my role at Buro Happold, I also co-chair the MEP 2040 commitment, which is part of Carbon Leadership Forum. So thinking about the embodied carbon and the operational carbon of MEP designs, and combining that with things like Architecture 2030 and SA 2050, and really thinking about that with this kind of wider coalition of individuals who are interested in sustainability. So the question around what data sources you use is quite difficult in these kind of emerging spaces. So environmental product declarations are produced by manufacturers. It's basically saying all the way back in your supply chain from the raw material stage, how much carbon was accumulated by the equipment you used to mine it out of the earth. And then you transport it to a manufacturing facility. And then maybe you had to go to another manufacturing facility before it actually arrived at the doorstep of your construction site. So thinking about all those different stages, that's memorialized in something called an environmental product declaration. And those are ISO verified documents. They have very clear fields inside of them. One attribute is called global warming potential. That's embodied carbon. So there are data sets for these things. A lot of them sit behind paywalls, which is really unfortunate, but there's a lot of data combing you have to do. So I understand why they sit there, but there are some efforts like EC3 is a really great, there's a plugin actually to Revit that you can get for it. But Building Transparency, who owns EC3, it was an effort to really kind of democratize the ability to look at this concrete versus this one versus this one. What's the industry average? What number should I be looking for? Really making that accessible to people. So actually within BHoM, we have an adapter for EC3 so that we can pull in those EPDs and being able to use them right in our designs. So it just depends on how you choose to leverage all of that data that is out there. But we do have this kind of continuous issue of things sitting behind paywalls, but it's not any different from someone saying, I need to reference ASHRAE or I need to reference the International Plumbing Code. There are these kind of different industry bodies that you trust for guidance, right? So you would want to also memorialize that data. So we have lots of different data sets that different experts will use, but I think an EPD is something that everyone will use eventually because it really anything that has materiality will require EPDs in the future to verify the amount of carbon in them. But
so that's really interesting that this EPD part, because if we're talking about the actual life cycle from raw material to end product, and the realities of manufacturing are that things are not always manufactured in the same places from the same sources. So these EPDs are dynamic. They're not static. It's not like the data is the same for every, sometimes depending on what you're talking about, every batch that gets delivered. So from a, I guess from a, you kind of have to look at it two ways, right? Does the market want to see aggregate information for EPDs per material thing that is like combining multiple EPDs into like a general tolerance or range, right? Versus, okay, now that's what you said you were going to buy, but this is what actually arrived on site, and then comparing the actual install versus the planned install. I wonder when that's going to become an issue.
There's a balance, right? I think you want to know the 20% of your building that is responsible for 80% of the carbon. And I think that's why we initially said, let's focus on structures. It's easy. It tends to be very few raw materials. It's kind of easier to track in the supply chain. It has a lot of mass in the building. So yes, there's variance, of course, in terms of the raw materials for the steel supply chain for one particular company. Maybe you have 10 suppliers of the iron ingots or something like that. There's variance, of course. And I think producing an EPD, you're stuck with that number, but I think that it should be representative of the general picture from that manufacturer. There are sector-based EPDs, which are kind of produced by larger bodies and saying, in North America, 3,000 PSI concrete is this, so that you have a baseline to be able to judge from. But some places like San Francisco Airport just set their threshold for, I think it was like 110 kilograms of CO2 per can't remember if it's volumetrically based or mass based, but they're setting these thresholds to say, we don't want concrete that's more than this number. So that's what you have to comply with. The state of California is doing something similar as well. So I think we'll start to see more of that. So you want more accurate information, but agreed, supply chains are very variable. And starting to think about this also through the ethics lens of who produced this concrete? Who mined the aggregate, the sand, the cement that I'm using on my project? And what conditions were they living in? What were their working conditions? So I think thinking about that human picture and how we start to get that information, it's just, you can imagine with a global kind of market, what that looks like. So trying to tackle problems like that, one team, one person, one organization can't do that on their own. You really need to work in a collaborative way to be able to solve these larger intractable problems. So I think that's where we need to go. And I think that's why it's so important to have open source code so that you can actually work together and there's no barrier there stopping you from working together and putting your algorithms and your data sets out in the open so that people have more confidence in what you're doing, but also just the ability to work with each other in this open way. I think we're not really used to that because of the structure of kind of how projects have been traditionally laid out in AEC.
So you're, as I think about, approach, deployment, learning, and integration, like those are the stages of any kind of systematic process. And we are very much in the approach stage right now. And what that then makes me think of almost immediately is this phrase wrapped around the axle. So now is not the time to get wrapped around the axle of all of those details. And, you made your point with the Pareto principle, the 80-20 rule, right? Like, let's be focused right now today on building approaches that will build a system that we can continue to refine as we get better and better at collecting the data, providing the data. I love your term, democratizing the information. I mean, this is not an industry thing. This is a global economic thing. And there are going to be economists that I'm sure are already focused on what this whole thing means and the impacts here, there, and everywhere. And so it's not just an AE thing, like you said, it's a much bigger thing, but that doesn't mean that we can't be really striving to get that approach part better and better, like incrementally better as we go around. So that's really exciting. It'll be interesting to see when we get to the deployment phase and then the learning phase of this whole conversation. I'm really excited. I'm thinking 5 years from now, looking back at these interviews and being able to go, my God, how far have we come since we were just talking about this? Because it's like exponential change that's going on. So because it's exponential change, what is your advice to our industry to prepare and get on board, because it's coming? This isn't something that you get to choose to ignore. It's like evolve or die almost is where we're going to see that in in the next several years. So what's your advice in the here and now? What's kind of like takeaway so you can do something with advice?
I would just say, regardless of where you are on your journey of learning a computational kind of approach to design, start now in terms of upskilling yourself. So I think the best way to do that is through a tool like Dynamo or Grasshopper, and really just thinking in this kind of, if I want to accomplish X, I need to do Y and Z, and really thinking through input, process, output. That's as simple as it is. That's how a computer thinks. So I think just thinking about, what are your inputs? What are your data sets? What are the points in your model you need to get to? If you're looking, let's say you want your window to wall ratio, you need your windows and your walls in order to determine that, right? So thinking through these kind of, you can start with a simplistic type of algorithm, but what's the process in between? What's the little bit that's going to get me to that number that I want at the end of the day? So I think thinking through that logic, and Dynamo and Grasshopper are great ways to start that. And then you can actually start to encode that in hard code, written code, text-based code, so that other people can leverage that as well. So I think just thinking in that way of, you don't want someone to have to repeat that process over and over and over again. And I think that's what we've been stuck in, because you always want to go back to first principles of the way that you design something, but you can encode that so that someone else can learn it, of course, so that they know how to apply it properly. And I think that's always the kind of fear mongering that goes on in our industry is, but what if people stop learning the first principles? They still need to learn that. But I think making it easier to leverage that as you're doing your design, so that you can continue to think about these kind of intricacies of engineering, rather than kind of like rote modeling that you tend to do in without even thinking about it. And I'll say it's kind of therapeutic to just place things inside of a Revit model. It's a nice activity to do that's monotonous. But I think just thinking about more interesting ways. And I think when you start to really jump into visual programming, it's kind of like you get a high from doing it every time, because it's really exciting to be able to approach your design in a different way and use your brain in a different way. And I think once you start to do that, you don't lose that kind of lust for working in that way. So I would say jump in there, but the sky's the limit. There are really so many exciting things we could do. And I think now we're getting to the point where tasks where people are like, well, a computer can't do it the way that I can, because I have these 50,000 rules that I comply with. But we really are starting to see artificial intelligence leveraged in our bits of code that we're putting into BHoM now, to be able to do things like tagging the way that a human would. Well, I use 45-degree arrows in this scenario and 90-degree ones in that scenario. And I don't like when things hit each other, and I don't like to cross through walls, and all of these kind of intricacies. You can encode all of that, actually. And I think just getting people talking. I work at a global firm. There was a period of time where I traveled to all of our offices once per year. So I think really just breaking down those barriers of thinking, well, it's different here. Actually, thermodynamics and physics don't change. So I think being able to encode that is so, so valuable. And I think just getting people to talk and share their workflows with each other, it's really incredible what you can accomplish with computation.
So yeah, that's very interesting. Well, I'm really excited. I think that this panel, the robotics, AI, and blockchain, is going to be an eye-opener for a lot of people who are attending. It's really kind of a bit of a crystal ball, in as much as one can look at a crystal ball and see that, you know, things are coming, things are changing. They're always changing, but there's some groundbreaking things that are going to cascade in their impact throughout the whole thing. What are you looking forward to most? If you could pick out one thing that everybody in that room would remember from what you're planning on sharing, what is that one thing? What is that one thing?
I think working in a more transparent, collaborative way. And I think that it maybe is antithetical to the idea of working in a computational manner, but I think that it really does facilitate people working together. and sharing their expertise, because when we start to do that, you can get to more meaningful outcomes. So rather than just designing for a window to wall ratio, and that's something you need to know when you're doing the energy model, you're starting to think about the daylighting, the well-being of the occupants, like I said, the health hazards for the building. There's so many different things we can start to think about if we start to pair our expertise together and thinking in this more computational way. But I wouldn't want that to be overwhelming to the point. I think the title of robotics, AI, and blockchain feels overwhelming. I think that's like, okay, well, I'm 15 steps behind that. So what do I do today? I think there are things that you can do today to be able to facilitate the kind of slow growth of computation in your company and the slow integration of that kind of mindset. So I would say just start working and talking and kind of thinking about these topics that are emerging, because they're coming, and you want to be prepared for that in the industry. So get ahead of the curve. And I think that's an amazing way for women to kind of differentiate themselves and being able to stand out in a market that hasn't changed very much in the last 50 years. So I would just encourage everybody to hop on the bandwagon.
Excellent. Thank you so much. I really appreciate you taking the time. And we're getting so close. It's going to be a really great conference.
I'm really looking forward to it.